Hello, I'm Anthony Hinton from David Fickling Books, and we are delighted to be the publishers of a brilliant new science series called the Explodapedia, written by Ben Martynoga and illustrated by Moose Allain. So Ben, starting with you, what is the Explodapedia?
So the Explodapedia is an exploded encyclopedia. So the basic idea is that each of the books covers a really big idea. It's eventually going to cover all of nonfiction, but we're starting with biology. And so we want these really gripping, detailed, in-depth books about the big ideas in science that really matter. And we want to make them really fun and easy, express why these topics really matter, why we all need to know them.
Yeah. Perfect. And the first topic and the first book is on the cell. So can you tell us why the cell is the most important starting place for a series of biology books?
Okay, so the cell is where all of our stories start, right? I mean, if you look out there on a night sky, there's a huge universe out there. But this particular planet we live on, it's got life. We know it's come to life. And that's the most amazing thing for me. And there would be no life without cells. Cells are the fundamental building block of life. Some people call them the atom of biology. They're what everything else is built of. So that's why cells really matter and are really exciting.
And Moose, to turn to you,
yes.
These books are full of amazing illustrations, brilliant, glorious double-page spreads, but also some quite technical drawings as well. From an illustrative point of view, how did you find communicating the ideas of the cell?
Yeah, hello. It's just very exciting. I think any artist or illustrator enjoys a challenge, and I don't have a scientific background. The last time I drew anything like this was probably in biology O level. I'm that old. So it was just really exciting trying to get to grips with it, really. And not knowing anything about science, I had to understand what was going on, these quite complex ideas that Ben has brilliantly found ways of kind of explaining to people like me who are a bit simple when it comes to science, and then trying to find ways to put them on the page that will help everybody to understand it. And it's quite a process of back and forwards until we get it just right.
Yeah. And Ben, could you talk a little bit about how you write for Moose's illustrations, and then Moose, how you kind of respond? Because I know it's a real collaboration between the two of you.
Well, it is, yeah. So, I mean, the first principle when it comes for writing is I want to make them really conversational, and really easy. We don't assume any real knowledge about science, but equally, we don't dumb anything down. Nothing's simplified. So you're getting the real up-to-date science. And as I'm writing, yeah, I'm really thinking hard about what the words can do and where images can be really useful. And yeah, there's another important player in this story is the series editor, Helen Greathead, who's worked on a lot of nonfiction kids books before. So we get our heads together and think about where illustrations really might work. We come up with a brief. We pass it over to Moose, and Moose then brings in his own amazing creativity and ideas and reinterprets that and usually comes up with some amazing suggestions. So,
yeah, there's another really important person in the process as well. That's Alison Gadsby, and she is the book designer. So she lays it all out for me. What I tend to get is a document through on email, which has got all the spaces. It's got all the words and then all the spaces where my drawings are going to go. And I get a set of instructions, like it could be anything, like a very complicated technical thing I've got to draw, or it might just say cartoon. One of my favorite instructions was just simply said flatworms looking smug. So I had to sort of try and interpret that. You can have a look in the book when you get to that page and see whether I've done a good job or not. So I'll have a set of instructions of what needs to be drawn, and Ben usually sends me some reference points for me to look up on the internet so I can see how things look. They might be sort of, computer generated images, and then I have to interpret interpret those kind of things. And some of the things we've done, which is always exciting, when Ben will say, well, no one's really ever drawn this before. And those are really exciting bits.
And Moose, as someone without a science background, as you said, how did you find kind of getting to grips with the science in these books, and what kind of sort of advantages did that give you, as well as sort of obviously needing to understand?
Well, I think I'm a good guinea pig for Ben, to try out his ideas on. If I can understand it, then anybody, from the age of 10 upwards can probably understand it. Because I don't understand science, I think, or I'm beginning to, but I think we have a tendency to think of science as being a sort of separate subject. Maybe it's the way we're taught at school, that you do different subjects, but actually the books are about history, they're about geography, they're about incredible people who have curiosity and imagination. It's very easy just to think of science as being a slightly dry, boring subject, but it's not that at all. And so I'm as likely to be drawing historical figures who have made the first microscope as I am to be drawing the inside of a cell. And so there's always something really fascinating, and I'm learning so much about all sorts of different things, all sorts of different subjects. Science encompasses everything, really.
Absolutely. And Ben, you do have a science background, so could you tell us a little bit about that, and then also about why it's so important to be communicating science to readers as well?
Sure, yeah. So after school, I did, well, 2 great big degrees in biology, including a PhD, and then I spent nearly 10 years in labs, various labs around the world, trying to get to grips with how the brain grows and develops. So I was, every day I was like peering down microscopes and watching living brain cells growing and trying to work out what their genes were doing and things. And it was an amazing thing to do. I was seeing things that no one had seen before. But I've always loved sharing these ideas with the world and why they really matter. And as Moose was just alluding to, there's so many kind of amazing stories in biology. And I've always had this feeling that they're too good just for the scientists to know them. So I wanted to share them. So yeah, a few years ago, I decided to take a break and get out of the lab and into the real world and start writing about these. And yeah, it's an amazing thing to do. And yeah, these books are an amazing platform to do that and bring in the amazing visuals from Moose and make these really nice books.
And could I ask both of you, do you have any favorite facts that you've discovered in making these books?
If I might start, one of the things that absolutely boggles my mind is just how complex tiny things are. So, the first book is about the cell, and these are things which are so small you can't see them with the naked eye. You have to look at them under the microscope. But what's going on in each cell is we describe it as a city, and it is like a city. It's like got factories and transport systems and manufacturing, and all these things are going on. It's an incredible thing, and there's so much of it packed into such a tiny space. And I think it's quite hard to get your head around that, really. So that's really fascinating. And so one fact that's amazing is that the nerve cell in a blue whale could be up to 30 meters long. So this is something that's so thin that you can't even see it. It's absolutely tiny, and yet it's 30 meters long, and it's strong. And there's lots of things in life that we can kind of relate to because we're humans, and we know about tiny little hairs and things like that. But this is beyond what we can really perceive of. It's beyond our everyday experience of things, and you really have to get your head around it. And I still find the sort of tininess of things amazing as I'm working now on our sort of 4th book in the series, and these things come up all the time. So that's one of my favorite facts, I think.
Yeah, and it has to be said that that's a great example of when Moose was talking about the little worlds inside a cell. When we were writing the brief, I was like, wouldn't it be cool to go inside a cell as if you were floating through it? And that's a kind of wacky brief. I wouldn't know where to start drawing that personally, but Moose came up with and Alison and Helen together, we came up with this amazing scheme. Whereas I love that chapter, Cell City, when we're exploring the innards of a cell. But yeah, in terms of my favorite fact from the cell, I think it's one, I didn't learn it when I was writing it, because it's a fact that sort of all biologists and everyone that's been exposed to biology sort of knows that life on Earth started once, right? So we all trace our origins back to one cell, the very first cell. And that cell becomes a character in the cell book. It's called Luca for a very good reason, the last universal common ancestor. But the more I think about that fact, that life started once and we all are related to one single cell, it never stops boggling my mind. It really does make sense to think of me, Moose, you, Anthony, these pot plants, the birds outside. It's almost as if they're all parts of the same living thing that came to life about 4 billion years ago and is still thriving now. So, yeah.